right, shh, quiet down, please. I'm coming. I know. I'm coming. Nolan is gonna put the answer for the warm up. Pay attention to Nolan.
Nolan, how did you get that?
You didn't want me to do that? I'll put it in the calculator.
Well, I have 8. So I have the 8.
Good job.
He's like that.
Is it a tree? Oh my god, they already made a suit. Yeah, they made a suit.
Wait, what?
Wait, what?
Oh, never mind. You're good, you're good.
Why are you judging me, man? Jeez. You judge too much.
Thank you, Nolan. Also, I saw the soccer pictures.
Oh, from Olive?
Yeah. I thought you were cold.
Yeah, we call them Eve, bro.
I'm like,
We all get confused, I guess.
because your head is down and I see blonde hair and I'm like, wait, which one is that?
I know, it's like because he dyed his hair and then we keep it wild. My pictures are fire. My pictures are fire. The goal celebration for that was like, why is he hushing? It's his whole deal. How honestly the hush?
It's hot.
Yeah, in the picture. He had the silence. But it's like, bro, it's your whole deal.
I didn't see that one.
You see that
I
one?
saw another one. It's just like,
It's creepy. It's like, that's your whole deal.
it's because there was a lot of salad.
There was, yeah. No, he said he's going to do no matter what.
No, there was literally like, where I was sitting, there was like a group of guys that would like more.
All right, shh, quiet down, please. Yes, Lindsay.
Okay, can we draw like any kind of line on the what?
No, it must be a carrot hat.
What if we make it like a wizard hat? So it's like
No. All right.
But if it was like a hat, but it looked
No, making special hats. Why likes that hat and that's it?
If I do it on the test, will you mark me polished?
No.
What if I put a different letter?
All right. Hopefully, you guys got an R value of negative 0.851. The equation is y hat equals 33.12 minus 4.69x. Would we want to use the equation to predict the date of first bloom when the average temperature was 8.2 degrees Celsius?
No.
No, it's too far out of our range. Highest temperature was 6.2. 8.2 is way higher than that, so we wouldn't want to. Did I miss signing off on anybody's homework? I'll be there in a minute. Yes. Over here? No. All right, Wesley. Today I am going to teach you a new trick on the calculator, and I don't want to have to repeat it 27 times.
Okay.
Okay.
You're gonna have to. But it's only 22.
I don't want to have to repeat it 3 times. 2 is pushing my patience.
But what if you repeated it?
I can borrow your charger.
Of course.
Thank you.
All right. Does anybody need a calculator before I get too far into this? Because I am going to teach you a new trick on the
What
calculator.
about like 4 times?
I know what you mean. You pick cookie. All right, residuals and the LSRL. What is a residual? What does the word make you think of? Residual. Leftover, which is pretty much what a residual is. How do you think you would find a leftover in math? Would we add, subtract, multiply, or divide? Subtract. So to find a residual, excuse me, we are going to find the difference between our observed y, the actual data, and our predicted, the y hat. So you might see the formula. It cracks me up. They put resid because, you know, cutting off those last three letters are really important. You take the actual minus predicted. That's how we find a residual. You will need to know that for the test. No, it's not one of the formulas you are given. All right, so in the warm-up, Nolan came up and gave us an equation. He gave us y hat equals 33.12 minus or plus? Can't remember. Minus 4.69x. What made that equation the best fit line? The calculator said so. Well, the calculator does a bunch of math that creates the line that makes the sum of the squares of the residuals as small as possible. And that's what makes it the best fit line. Sum of the squares of residuals. And that means that it is the least squares regression line, also abbreviated as the LSRL. So if in your homework it says something about LSRL, or on the test it says LSRL, it's just asking you for the equation that the calculator gives you. Okay? The calculator, like I said, does a bunch of math that is making the sum of the squares is, that's a tongue twister, sum of the squares of the residuals as small as possible, and it finds our slope. First of all, is slope in the equation A or B? B. It finds the slope by taking your R, so your correlation value, and multiplying it by the standard deviation of your Y divided by the standard deviation of your X. Would you guys all agree with me that I could rewrite this like this? So our slope of our least squares regression line, as our standard deviation increases by 1 for the x, our standard deviation in the y increases by our correlation coefficient. There might be a question about that in your homework tonight. As standard deviation of x increases by 1, the standard deviation of y increases by r. The y-intercept, which is a up in this equation, is found by taking your average y minus your slope times your average x. Oh, and then, that was nice of me. Right here, I summarized this, what I just said. The formula for slope tells us that the change from one standard deviation in x corresponds to a change of r standard deviations in the y. So we're going to go back to that GPA ACT data, and we're going to do these formulas to show that we can actually get the same slope and y-intercept that the calculator gives us. If you got rid of this data from your calculator, go ahead and put it back in.
Can I get rid of what we did on the warm-up, that list, or do we need that?
Sure, you can get rid of the warm-up data. Oops, hold up. All right, so what information do we need to know to find the slope and the y-intercept? We move back up to those equations I told you. We need to know what r is.
You find the standard deviation
We need to know the standard deviation of y and x.
and the average of y.
And we also need to know the average of both. Thank you, Seth. Who can remind us how to find R? What buttons do I press? Stat Calc 8. Sorry, I have to cover the list. For whatever reason, when I put the calculator on the right side, it always gets glare. So, Stat Calc number 8. I have them in list 1, list 2, and we get R equals 0.955. So let's put that in our little list of information we need to know. Anybody remember how we find our average and standard deviation? Stat, go over to calc, 1 var stats. Now, if you've ever noticed when you hit stat and go over to calc, right below 1 var stats is 2 var stats. It'll do the same thing as 1 var stats, but for 2 things at a time. So we're going to go in there. My X list is list 1. My Y list is list 2. Leave frequency alone. So there it gives me my X average, all the other information. And then about the bottom of the screen, it switches over to the Y's. So I get all my averages and standard deviations in one step rather than having to do the 1 var stats on each list individually. Wesley.
Can you go back to finding R, please?
Stat.
Wait, can you
Stat.
Do it? Can you do it, please? I need to see it.
Stat. Calc. 8.
And then X.
Those are where I put my data, so I just
You
hit
have
enter.
you have the GPA as list 1 and the.
ACT is list 2, yes.
Okay. Oh, mine doesn't say. I don't know.
It wouldn't matter. I'm gonna be in the areas.
I'm not sure how we fixed the R thing.
I mean, it just doesn't show up.
All right, Wesley,
Yeah.
listen. You ready?
Yes.
Hit second 0.
Where?
Where's 0?
0.
Then you're going to hit the x to the -1 right below math. So it jumps to the d's.
Are you in catalog?
Yes. Scroll down till you get to diagnostic on. Hit enter. Hit enter again so it says done. Now it'll give you R. Don't miss my class. I did that to everybody's calculator the other day.
Thank you.
Uh-huh. Your calculator was just malfunctioning. You're good. I'm mad at Wesley. All right. Hopefully somebody wrote down our averages and standard deviations for me, please. What was the average X?
3.4.
And the standard deviation of X?
0.4.
Average Y?
24.
And standard deviation for Y?
4.817.
4.82.
7. What's that?
Okay, so 4.82 if I round, right?
What?
I rounded.
Why are we
No.
rounding that? To
You would round up to 7. 4.817.
It'd be 4.8.
8.2.
Oh, yeah, go ahead.
Okay. Okay. All right, so now we're going to find our slope and our y-intercept using the equations. Yes?
Will you release Lisa Bernstein to attendance, please, with her thing?
Yes.
Thank you.
Remind me when she comes back in to tell her.
Lisa's staying.
They just called for you, Lisa, to go down to attendance. All right, so slope. We're going to take r times standard deviation of y divided by the standard deviation of x. What do we get? .82 divided by 0.4 and then multiplied by 0.955. So we get 11.50775. And then to find our y-intercept, we do the average y minus the slope we just found times the average x. Average y is 24. Our slope we just found times the average x, which is 3.4. And we get negative 15.12635. Yesterday, I had you guys find the equation of our best fit line for the GPA and ACT data. Anybody remember what we got yesterday from the calculator? We did get that. The calculator actually gave us y hat equals negative 15.1 plus 11.5x. So why did we get slightly different?
Because we rounded.
We rounded, specifically on the standard deviations. I for sure rounded the standard deviation y, which is going to throw off our slope slightly, but not by much. And then because we use this slope to find the y-intercept, it'll be a little different. Now, something cool. I find it cool, but I am a math teacher. The point average x, comma, average y shows up on your least squared regression line. So we're just going to plug it in, show that it actually does happen. By the way, I will have a question about this on the test next week. So make a special note to yourself somehow. So, let's go with this one, just because the decimals are smaller and I'm feeling lazy right now. So our average x is 3.4, average y 24. So we know that y hat is equal to negative 15.1 plus 11.5 times x. So we're just going to plug 3.4 in for x and double check. We actually get 24. Sorry, I'm going to kind of cover it up. 11.5 times 3.4 gave us 39.1. Then when I add the y-intercept to negative 15.1, we get 24. So it is a nice little piece of information that I will ask about on the test. Can I flip?
Yeah.
Thank you. All right, so residuals left over. I'm going to flip back. Gosh. Residuals are found by taking the actual piece of data that we have and subtracting our predicted piece of data. Actual minus predicted. And I have to abbreviate predicted because I ran out of space. So we are going to go through and find all the predicted ACT scores for the GPAs that we have from our data set. We're going to put the predicted ACT scores there. We know the actual ACT scores, and then we can find our residuals. So we have, just so we don't have to flip back and forth, our equation is negative 15.1 plus 1.5x. So if I wanted to find the predicted ACT score for a GPA of 3.0, I put 3 in for x, and I can find my y value. So 11.5 times 3 plus a negative 15.1. So I would get a predicted ACT score of 19.4. You guys are going to find the other 5 predicted ACT scores.
Oh, that guy.
All right, what's the predicted ACT for a GPA of 3.5? Thank you, Shania. What about for a GPA at 3.1?
20.55.
4.0?
30.90.
And 3.7.
27.45.
And we already know the 3.1, it's 20.55. While you guys were doing that, I put the actual ACTs in that column so you can copy them down really quick and not have to flip back and forth. And then we're going to find our residuals. So residuals, we take our actual piece of data, the Y without a hat, that's your actual data, and you subtract the predicted data. So we have our actuals here and our predicted ones there. So our residuals are going to be the difference. So for the first one, 19 minus 19.4, I get a residual of negative 0.4. If I take 27 minus 25.15, I get 1.85. 22 minus 20.55, that would be 1.45. And please double check my math.
Doing good so far.
Okay, good. 31 minus 30.9, that'd be 0.1. It's when I start doing the negative ones I tend to make mistakes. 26 minus 27.45, that should be negative 1.45. And then 19 minus 20.55, negative 1.55. Right?
Yep.
No.
Yes.
All right. Now, with residuals, what we do is we make a residual plot. So that's what this space here in the middle is for. We're going to make a residual plot. When we graph our residual plot, we are going to graph the x versus the residual. So x versus residual. And notice our residuals, we have positives and negatives. So when I draw this, you can see I have one below on the next piece of paper. You're going to have your y-axis, and then you want x going through the center, because we are going to have stuff above and below. Our x is, yes?
Why did you say 3.1 but the actual X are the same? I mean, different?
Because back in our actual data, this student with a 3.1 had a 22, and this student had a 19.
Okay.
So, like I said, we're going to do the original x, which is GPA. GPA, we're going to go from 0 to 4. That puts 2 in the middle. 1, 3. Suppose I should put that line there. And then 3.5, 3, 4, 1, 2, 3, 4. 3. I only put the hash marks there because the GPAs stick between 3 and 4. And then on the Y, our highest residual is 1.85, so let's go up to 2 and put 1 in the middle. And then lowest residual is negative 1.55, so let's go down to 2. 1 in the middle, negative 1, excuse me. And I should label my y with residuals. By the way, a lot of you lost points on your ogive because you didn't give me any labels. Alright, so GPA at 3.0, we had a residual of negative 0.4. So 3.0, that'd be almost to that half. So we'll say right there-ish. Not going to be perfect because we're doing this by hand. GPA at 3.5, residual of 1.85, so almost up to 2. We'll say there-ish. Then we have a GPA at 3.1, a residual of 1.45, so almost up to my 1.5 mark. GPA of 4 point, residual of 0.1, so just barely above the x-axis. 3.7 had a residual of negative 1.45, so we'll say about there-ish. And then the last one, 3.1 and a negative 1.55. When you make a residual plot, you want to have no discernible pattern. You want to have about half the points above in the positives and about half below in the y's. If a residual plot has no pattern, that means our least squared regression line is a good fit. Alright, now we're going to do this on the calculator because doing it by hand with 6 pieces of data is not bad. But as you know, data sets very rarely only have 6 pieces of data, and it would suck to do all of that by hand. So I'm going to show you guys how to do this in the calculator. I did try to be proactive here, and I typed up the steps. So down below in that little orange box I just made, those are the steps. As best I could make them make sense. Hopefully they do. But if you are doing this in your homework, you could go back and look and follow along. So first thing, we need to put the least squared regression line into y equals. So we're going to put the equation where I always tell you to make sure it's empty so that we can make scatter plots and stuff, right? So up here, top left, y equals. We're going to actually put an equation in there. Our equation, I put up here, negative 15.1 plus 11.5. By the way, before I go further, negative is down here. This is a minus button. These calculators get angry if you don't use negative and minus correctly. So negative is down here, that's the minus button. Now, I need to put in the variable x. I know you guys know you can type letters with this and type words and stuff. The x we want is up here next to alpha. Alpha, and then right here, x comma t comma theta comma n. That's the button we want to press to get x. If you use the alpha and then whatever it is to get the x, it won't like it. You have to use that button. Everybody good? Got it in there? All right, so now we're gonna use our lists where we have the original GPA ACT data. We're gonna use the lists kind of like an Excel spreadsheet to create a list of predicted values and then a list of residuals. So you need to go into your lists, hit Stat, and we're gonna edit. We're going to make our predicted values list. So we're going to go over to list 3 and we're going to define it as Y1 of list 1. So go over to list 3. Just like when you want to clear a list, to define a list, you need to be up on the actual list name. So notice how I have L3 highlighted. To get that Y1, which by the way, Y1 is where we put our equation. So we're just telling the calculator to use our equation. To get to Y1, you're going to hit vars, not second vars like we've used before. You're going to just hit vars. Should take you to this list. You're going to scroll over to Y vars. Choose function, and there's Y1. It's the first one highlighted, so I hit enter. And it takes me back to my lists. And now look down here, it says list 3 is equal to Y1, and then I'm going to put parentheses list 1, or wherever you put your GPA data. So parentheses list 1, you hit second one, close my parentheses. Questions before I do the next step? Everybody has this down here? Which question? Go over, you are missing a list.
Yeah.
Go over to list 4. Highlight list 4. And then hit bars. Go over to Y bars. Hit enter. Enter. And now it's down there. And then put parentheses list 1, 3. Alright, so once you have this down here, if you hit enter, notice it pre-filled my list for me. If you compare those numbers to all the predicted ACT scores that we found by hand, notice they match.
Mine says invalid.
You probably used the minus sign instead of the negative sign when you typed in your equation. May I do the next step?
Yeah.
Okay. No, you need list 1, not 1. Second one. Did that fix it, Mason?
No.
All right, everybody good? All right, so now we're going to make a list of our residuals. Right now in list 2, I have all the actual ACT data. In list 3, I have all the predicted ACTs. To find residuals, I take my actual minus my predicted. So I'm going to go over to list 4. Make sure you highlight L4. You don't want to be in the first cell. And we're going to tell it to take list 2, my actual data, so second 2. And then I'm going to subtract list 3, second 3. So down here in the bottom, list 4 is equal to list 2 minus list 3. Once you have that in there, just hit enter, and it gives me all my residuals. So notice when I compare that list with the residuals we found by hand, they match. Are we good?
How do I get it to work?
Put your least squared regression line into y equals. That's all you're missing. It can't do anything with a y if you don't have an equation in there, Mason. All right. Good. Now we're going to make a scatter plot, which I showed you how to make the other day. When we make the scatter plot to make our residual, we're going to do our x versus the residuals. My x list, like I told you down here, is in list 1. And the residuals, my y list, are now in list 4. So when I go to second y equals, I'm going to go into plot 1, or whichever one you want to use. Make sure it's on. We want to use that scatter plot, the first one. X list, like I put down here, is list 1. We want the y list to be list 4, as long as that's where your residuals are. Everybody got this?
Yep.
Then we're going to hit graph. It may not give you anything because we made some weird graph yesterday. So then we hit zoom 9. And there's my scatter plot, our residual plot. It's what I made, just much more zoomed in between 3 and 4 only. Yes. When it says the error is a window thing, that means it doesn't like the window, it's using to All right. Questions. I will be honest, as I was going through what I typed in, I did realize that I kind of didn't type up the buttons you press to get that Y1 part in the calculator. So to get Y1.
So you're saying we all messed up because you messed up?
No, I just, like, if you were to go back to these tonight in your homework, you'd be like, hold up, where'd she get Y1 from? I didn't put those steps. I talked about them and we all did it together, but if you go back to reference this tonight, you'll be like, wait, what was it I pressed?
Okay.
So to get Y1, you're going to hit vars. Then you go over to Y bars. You choose function.
It was the second bars too, right?
No. Second bars gets us to normal CDF and inverse norm, which we used last chapter. Now we just want to hit bars. And then under function, it's number 1, Y1. So that's how we get that. I do apologize. I kind of glossed over that when I typed up the steps. Can I move up my paper?
Yes.
You guys sound so upset about that.
I'm tired. I'm not upset. I'm just tired.
All right, so how can we get a good idea, on average, how far off the least square regression line is in predicting ACT scores? There is a new thing, S. It's the standard deviation of the residuals. The average of the residuals should be 0. Remember, I talked about half of the residuals should be above the x-axis and half of them should be below. If I were to add all my residuals together and divide by the number that I have, I should get 0. If I don't get 0, I probably don't have a very even split above and below, and I probably have a pattern in my residual plot, and patterns in a residual plot are bad things. You should have no pattern in a residual plot. You do not need to know this formula by heart. Like I've said multiple times, I show them to you so that if you take the AP exam and it shows up, it's not a brand new thing. S is the standard deviation of the residuals. You are going, if you were to find it, you would take the square root of the sum of the residuals squared divided by n minus 2. So, S is usually just something that they give you in a problem. They'll say, oh, here's S equals, in this case, S is equal to 1.6. A lot of times they'll be like, here's the summary statistics. And in fact, in a minute, I'm going to show you a computer output that just says, here's S. That's how they give it to you. So for the GPA and ACT data, S is 1.6. You do need to know how to interpret S. Finding S, you don't need to know how to do, except for find it in the output that I'll show you on the next page. But interpreting what it means, we have to know how to do. So standard deviation, remember, tells you how far the data is away from the mean. So the standard deviation of the residuals tells us how far on average, like nowhere, just came out of nowhere. It tells us how far we off are. Now, he ruined my thought. That's okay. All right, so when predicting, and you should always put it in context. I didn't say interpret S in context. I just said interpret S, but it should always be in context. So when predicting ACT scores from GPA, the average error is 1.6 points. So on average, we're off by 1.6 points on the ACT scores.
So we go, since they got such and such GPA, they get such and such ACT plus or minus 1.6?
No.
No?
No. We don't add the error because we don't know whether we over predicted by 1.6 or whether we're under predicting. I did the actual math and found it for you guys. When we do problems, like on the next page, Lindsay, they just give you S. You're never asked to find S by hand.
Okay.
So I'm not gonna make you do it. That would be like teaching you extra information. The important thing is you know how to interpret S. All right, so I already said a lot of these things, but when you have a residual plot, it should be scattered evenly above and below 0. That tells you your least squared regression line is a good fit. And by good fit, I mean the line fits the original data well. If your residual plot is curved, that means your least squared regression line is not a good fit. There should be no pattern. Look for residuals that increase as x increases. We'll talk more about that tomorrow when we look at outliers. Large residuals mean outliers. Stuff that doesn't fit the data. Because a large residual means our actual data and our predicted data were very different from one another. And if our actual and our predicted are very different, we probably have an outlier in the actual data. And if I haven't said it enough, let's just write it together. Residual plots should have no pattern.
What if, like, the graph just happened to accidentally be perfectly linear?
The original,
Yeah.
then when you make a residual plot, you should still have absolutely no pattern.
It's not gonna always be like on 0 or something.
It would be pretty rare that your actual real life data is a perfect straight line.
But if it was,
Then I would guess, yes, your equation would hit all the points, so all your residuals would be 0. But that's not real life data. Real life data is never
what if you
perfect.
took like billions of points of data?
Who has the time to take billions of points of data?
A supercomputer?
I'm not a supercomputer, so I don't know what to tell you on that one. Sure, but no. It's never going to happen, at least not in my class, because real life data is not perfect. All right, so here, like I said, this is more like when you're asked to interpret S and stuff. They're going to give you, hey, here's the original data, here's the scatter plot, here's our least squared regression line going through the scatter plot. Here's your residual plot. And here is what they call computer output, a mini tab output. And down here is where you can find your slope, your y-intercept, and your S value. Which is why I said you guys don't need to worry how to find S, because they just give you S. You need to know how to interpret. So this example says a random sample of 15 high school students were selected from the U.S. Census at School database. Foot length in centimeters and height in centimeters of each student in the sample are recorded. Least squares regression was performed on the data. A scatter plot with a regression line is added. Residual plot and some computer output from the regression are shown below. A, what's the equation of the least squared regression line for predicting height from foot length? You go down to the computer output. I'm going to try and zoom in a little more. The very first column here says COEF, coefficient, and then it's got two numbers down below it. Next to one of them says constant. Is the slope or the y-intercept constant? Who said slope? The y-intercept is constant. The slope changes because it's being multiplied by x. So this first one next to the constant is your y-intercept. The other one, which depending on what your data is, will have one of the variables next to it. That is your slope. So I have my slope and my y-intercept, and I can go back up here and put y hat equals 103.41 plus 2.7469 times x. If you see the words percent of variation, no matter what it's talking about, so whether it's height, whatever the variables are in that situation, percent of variation is asking you for r squared. I will talk more about r squared tomorrow, but r squared shows up in this computer output as well. It is this one right here. Notice to the right of it, it says r squared adjusted. We don't ever use this one in this class. It will always be on the output because that's how the software program works, but we don't use it. It says ADJ in there, adjusted, don't use it. So for this one, what percent of variation of the height is accounted for? R squared is 48.6%. Use the information to find the correlation r. If I know r squared, how do I find r? Square root. So biggest thing I see kids do is they square root 48.6. You want to square root 0.486. Change it back to a decimal before you square root. Now, Tanner, I'm going to pick on you because I've been hammering this idea home in pre-calc, and you have me for pre-calc. What happens when we square root? Plus or minus. So when we square root r squared and get 0.697, there is positive 0.697 and negative. We need to figure out whether it's positive or negative.
Oh, I forgot the term. There's a term for it, right?
For positive and negative? Oh, when you square root it? I don't know what you're talking about. So, to know whether our r is positive or negative, you're going to look at the slope of your least squared regression line. Our slope is positive, so our r value is positive. If the slope was negative, then our r value would be negative. And then the last question, interpret S in the setting of the context. S, if you look at our computer output down here, it gets kind of jumbled up because it's hard to read, but S is this one right here. It's 7.95126, and I know I ran out of time, it tells you your average error. So how far our predictions are off. Hold on, I gotta stop recording.